So chapter 1C, I'll be discussing about Java client and server architecture. So we'll be discussing about how client and server architectures are being implemented in the Java environment. If you will see, most of the client and server applications today, especially the open source ones, are using Java as their main platform to perform Java and client and server connectivity. So we have plenty of application mostly written in Java. Mostly are client and server applications that provides connectivity with various clients distributed somewhere else and try to connect with the server. So mainly Java is the favorite programming language of most developers, which are writing applications for both the client and the server. So the famous one they are using today is RMI. Okay, so you will see later on what is RMI, and we will see how do they implement this RMI, what's the architecture involved in writing RMI applications. And normally when we talk about the RMI architecture, there are some terminologies and concepts you have to be clear of. We have the stub, we have the skeleton, we have the RMI process, marshalling and unmarshalling. Then we have the RMI registry, and then creating an RMI Java application. So these topics we're going to discuss today, and at the end of the presentation, I hope every one of you will be able to understand what is RMI. So RMI is defined to be as remote method invocation. From the word itself, we say remote method invocation, meaning we're trying to access or to call a method that is actually located remotely. It could be this method is stored on the server, okay, and there is a client accessing that method. Okay, so basically we know what are methods, right? We are actually doing it many times in our C# programming. So method is something like this. Let's say, for example, private void add numbers, okay, integer num1 and integer num2. So this is an example of a method, right? So this is an example of a method. Okay? So maybe what you'll be doing here is like this. Private, let's call this private integer int add numbers. Okay, and then we have here, let's say for example, a sum. Let's say for example we have sum int sum, and then we will do something like sum equals num1 plus num2. Okay, then we will do the printf or system.out.println. You can do like this, the sum is %d, and then you can do something like sum. So what will be the output of this code? Basically the output of this code is, anybody from the group, what's the output of this code? What is the purpose of this code? Why can I put it here? Cannot put my text inside. It's another text here. Sorry. So inside this, I have this int sum, num1 and num2, and then system.out.println. The sum is %d sum. So can anybody tell me what's the meaning of this code? This is an example of a method, right? Example of a method. So a method. Can anybody tell me what's the use of this code?
Doctor, this method use it for added the two number.
Very good. Yes. So this method is used. Yeah, very good, Ali. It is used to add two numbers. Okay. So it means that for this, or let me just revise this. Maybe we could do better. We have to do return sum because we are using integer here. Okay. So this method is actually correct. Anwar says the purpose of this method is to add two numbers, basically num1 and num2. Okay? And after adding this num1 and num2, it will return the sum. Return means it will give it back to any call that is requiring to add two numbers. So if you look at it, inside the parentheses, there are two variables, right? Have you noticed? These two. Have you noticed this one? Okay. So we call this actually arguments, or sometimes they call it parameters. Just the same. They mean the same thing. Parameters or arguments. Okay. So it means that in order for this method to run or to perform addition of numbers, it requires two things, num1 and num2. These arguments should be supplied by an external. Okay, it could be supplied externally. It should be supplied externally, meaning coming from an external entity. Okay, so like this, it should be supplied. So it means that in order for this to run, to add the numbers, it has to get num1 and num2, and later on we're going to add it and then return the sum. So I have this first method here. Okay, so this is the problem now. I can't, maybe I just have to delete this and run it in here, because I can't do tab for this one. Even space I can't do. So this is my problem. So int sum, and then we have in here sum equals num1 plus num2, and we'll go with return sum. Okay, get it? So this is something like this. So this is an example of how do we do class, I mean a method, right? So you know this one, you made it many times with your Java programming. So this is an example of a method. But in the RMI, we're going to invoke this remotely. Okay, meaning we're going to invoke an object or a method that belongs to an external entity. Okay, or maybe from a different machine. So in this case, RMI is used to build distributed application. So in order for you to access that, you have to use the library, which is java.rmi. So this java.rmi allows you to invoke a method, okay, that belongs to a different machine. So it means that if I'm going to demonstrate to you in an illustration, it would be like this. Okay, so this one can be residing on your server, maybe this. Okay, let me just demonstrate to you. So I will erase this because I need this for the meantime. Okay, so let me just also remove this for the meantime. Okay, so this is our method. Okay, so maybe this method belongs to our server. Okay, this one is stored in the server, let's say for example. Okay, so this method is stored on the remote server. Sorry for my drawing if it's ugly. Okay, so let's say for example we have our server here. Okay, our server, and our server is having an IP address. Okay, let's say for example this is in 192.168.x.x. We don't know the IP address. Okay, so this is our server. So meaning this method here is actually located on our server. And our client here, will be accessing this. So we have our client machine here. Okay, client machine. So maybe this client will be on 192.168. maybe x.y. Okay, so we have here a code. Let's say for example our code here, we have, let's say for example, private void button one, let's say for example. Okay, click, let's say for example, meaning if I click a button on my application in the client, okay, if I click the button one in the client, or let's make it realistic, let's call it cmd add.click button, then it will be doing this. It will do something like let's say for example this one is in assuming, okay, we will assume that this belongs to class server, okay, server add. Okay, this, the class name is server add. So using my client machine, I'm going to invoke this, and I will type something like server add. I cannot type here. Server add number is equal to new server add. Okay, so it means that this code belongs to a class which name is server add, and then we're creating an object which is add number. Okay, so please remember, this is our object. This one here is an object, okay, and this one here is our class. Okay, let me just put a note, this is a class, this is a class. Okay, so this class is located on our server. It's stored in the server, meaning a separate Java file is stored on the server, and a separate Java file is stored on our client machine. So what happens is that we are invoking this one here. So this is an object, so we call this one an object. Okay, so this is an object. Okay, so this is an object. Let me just delete this, and I'll write something here. Just put it in here. This is an object. Okay, so from here now we're going to call this, which is in the server. We're going to write something like, why I cannot click this one. Okay, so I'm going to call now like this, add number dot num1 equals, let's say 10. Add number dot num2 equals 20. Then we're going to invoke this. We will get, it says system.out.println. Let's say, for example, we will say sum is, and then we're going to do this one, plus, then we will call this, which is add number dot add numbers. Okay, like this. Okay, so do you get the meaning of this code I'm writing here? And from here we're going to access it using this one will be accessed using the internet. Okay, or if not the internet, maybe your network. Okay, so we're going to access it using the network. So look at this. So client 192.168.x.y will be accessing this code. Okay, this code, which is stored on the class which name is server add. It will be accessing it. So what will happen now is we have to write the code in here, server add, which is this, the name of the class. Actually, to complete the code, it should be like this. Let me just erase it so that you will see it clearly. Let me erase what I have done. Oh, very sad. Actually, if you're going to revise this code, it should be complete like this. It should be like, you should have something like on the top like this. It should say public class server add. Okay, it should be like this. And from the bottom we have this. It should be like this actually. Okay, so using the internet we are trying to access, okay, the code here. That's why you will see we will be using the class, we will be invoking the class name which is residing on another machine, which is server class. So you will see we have done it like this. Have you seen this one? This, we invoke it, okay, and then we made this add number equals new server add. So this class here, this is actually the class, okay, and then from here we create an object which is add number. This object can be any name, okay. If you want to call it Ali, no problem, okay, it's only a variable, okay. This one is a variable only. So what we have done is add number dot num1, which is this, okay, meaning the value of this one will be coming from here, okay. Then int num2 will be this, okay, this is the value. So what I want to do is to display the sum by writing this sum is plus add number, this one, dot add numbers, which is this one. I call this here, okay. So when I send this using the button click here, the client will send this piece of request to the server, okay. It will send this to the server using RMI. It will send it, or remote method invocation. It will send this to the server, and the server will check if all the parameters required are in there, and then it will perform this code here. So after that, this method will be executed. Int sum equals num1 num2. If you will see it return, right, meaning return where to return? It has to return here. Okay? So the sum now will be returned back to the client. Is it clear? Any question here? Any question here? Please type it if you have, if everything is clear, please send message if you don't have questions. And if you have questions, please ask. So Rukaya says no question. Ibtisam says no question. Okay, very good. Okay, Hani says no question. So everything is clear, right? Good. So this is RMI, okay? Remote Method Invocation, meaning a piece of code or a method residing on a different machine. We're going to invoke it with different machine located on a different place. But please see to it, this is very important, that the machine requesting an access to that code should be having a JVM. Okay, what is JVM? Can anybody tell me what is JVM? What is JVM, my friends? Could you please tell me what's the meaning of JVM? JVM means?
Java.
Yes. Java. Continue.
Method.
Java virtual machine.
Very good. So there should be Java virtual machine. Okay, it's a prerequisite, okay? Virtual machine. So you have to take note of that. Okay? It means that the implementation should be like this. Okay? So let's say, for example, if the server, let's say for example here, I don't like it, it's very thin. Let me just remove this. Okay, let me add one object here, Bing image server. Okay, now just take one copy here, okay? Okay, then I'll take client. I hope you are seeing my screen clearly. Okay, I'll use this one. Okay.
Yes, it's clear, Doctor.
Thanks God. Okay, Control C, Control V. Control V. Okay. So I have these clients with me and I have these servers with me. So let's say for example my server is Linux. Okay. Then I have one client here. My one client is, let's say for example, Windows 10. Then I have one client here which is, let's say for example, Mac. Then I have another client here, let's say for example, which is Fedora. Okay. So all of them can do RMI. Okay, they can do RMI with our server here. Okay, they can do RMI. Okay, so this one can do RMI here. Same here. Can do RMI here. Okay, but see to it, all of them should have Java virtual machine installed, okay, or JVM, because the compilation requires Java virtual machine to run. Okay, so it means that the communication will not the communication of the remote method invocation will be happening in the virtual machine. Okay, they are being performed in the virtual machine, the JVM. Okay, so regardless what kind of operating system you are running, as long as you have Java virtual machine, and then this will work properly. Okay, so in order for you to install Java virtual machine, what is the software required? Anybody to access Java virtual machine? So you have to install what? Java JDK, okay? It's very important, Java JDK. So Java JDK or Java Development Kit, let me just write it in here. Java Development Kit, okay? It's very important here, Development Kit or JDK. So this is very important because JDK is having this package built in to install the Java virtual machine. So it's very easy to see that. You can go to Google and type, very good, this one. You can go with Java JDK. So you type JDK here, it will bring you to Oracle, okay? So this Oracle website will give you the Java virtual machine, so the Java SE, the JDK, okay? So the JDK or the Java, this one, you can get it in here and install it in your respective machines so that you could be able to deploy the JVM or the Java virtual machine. So going back, so in order for you to write a distributed system, distributed application, you have to see to it that JVM is installed for every machine, okay? Or else they won't be able to communicate. Now, the RMI has an architecture, and I want you to see this architecture here, okay? So we have the client, the stub, the RRL, and then we have the transport layer below, okay? So again, transport layer is responsible for what? Don't forget this. It's responsible for socket programming, right? So don't forget that one. Okay? So these are the components. On the side of the clients, we have the stub. Okay? And then on the server, we have the skeleton. And then both of them, they have RRL and then RRO. If you will see, it says there is virtual connection. Can you see this? This one here? It says virtual connection. So this virtual connection is actually running inside which one? Where is it running, the virtual connection? In the JVM, okay? And then you have your physical connection. Okay, your physical connection is actually running over your network, okay? So you have to put cable and IP address, so on and so forth, okay? So basically the communication would be between the JVM to another JVM will be doing the communication for the RMI. But of course, all of this data should be passing over your network. That's why you require here a network connection, okay? So if you will see, inside the server program, a remote object is created and reference of that object is made available for the client using the registry. I'll discuss it to you later on what is this registry all about. And the client program requests the remote objects on the server and tries to invoke its methods. Same example I was giving to you in the whiteboard, if you have noticed earlier. We requested, sorry for this, we want to access the object, okay? That's why we have here earlier this add number. This is our object, and this object belongs to the class server add. So this is the main goal of RMI, the ability to access the remote objects. But to do that, this architecture should be understood fully, and you have to write the code in such a way you have to at least satisfy the requirement of each component in the architecture. Do you have any question here as far as the architecture is concerned? Is the architecture clear to you? Is this clear, the architecture? Okay, so let's proceed to the discussion of each. Of an RMI application, we have the following components. Basically, we have the transport layer. You know this one, right? So this layer connects the client and the server. It manages the existing connection and also set up new connections using socket and ports. Correct? And then we have the stub. What is a stub? A stub is a representation of the proxy of the remote object at the client. It resides in the client system. Please remember this, okay? It resides in the client system. Stub is in the client system. It acts as a gateway for the client program, okay? It connects it to the server. The skeleton is the object which resides on the server side. So the counterpart of the stub is the skeleton. So you have to look at this. The stub communicates with this skeleton to pass requests to the remote object. So in the example earlier, in the one I've written in the whiteboard, so meaning this one is a stub, right? This one is a stub, and this one here is the skeleton. Okay, skeleton. Okay, so why? Because the client is requesting this object, this class, from our server. So this is our skeleton, this is skeleton part, and this is the stub part. Okay, so I hope that is clear for you. And then we have the RRL. RRL means Remote Reference Layer. It is the layer which manages the references made by the client to the remote object. Okay, so it's the referencing part. It is the layer that manages the references made by the client to the remote object. Why it is like that? Because sometimes the client machine is not only requesting one method. You have to remember that. Sometimes your machine, let's say for example this Windows 10 here, may be calling, let's say for example the add numbers, right? Okay, so it might be calling this, or also it might be calling let's say for example subtract numbers. Okay, subtract numbers. Okay, so the RRL here, the RRL, okay, it's like a list of table. It's like a table, I mean, that lists down all the requests made by the clients. Let's say for example this Windows 10 is 192.168.x.a. Okay, I don't know the IP address, so I put .x.a here. Okay, so in your RRL you will see like this. Let's say for example 192.168.x.a. so it is requesting, let's say for example it is requesting add numbers. Okay, it's like this. Okay, and also it will say 192.168.x.a. it is requesting subtract numbers. Okay, so this is the content of the RRL. It's recording which method or which object each machine is requesting on our client, in our server here through RMI. So let's say, for example, this MAC here, our MAC is having an IP address of 192.168.x.b. I don't know the IP address, so I'm writing this. Then let's say, for example, it is it's requesting, let's say, for example, divide numbers. Okay, let's say, for example, so in the RRL it will say that the IP address 192.168.x.b is requesting for the method divide numbers. Okay, why do we need to have the registry or the RRL? Anybody from the group? Why do we need to have this? Why it is very important to have this RRL? Anybody? Anybody could tell me why it is important that we need to have this RRL or this referencing here, the remote reference layer. So why it's important? Anybody? Anybody can give me an answer about this? No one? Anybody? So the RRL is very important for the reason is that it should track which machine is requesting what and requesting which. Let's say, for example, if there is no RRL, how will the server know which value should be returned to each client, right? So let's say, for example, if 192.168.x.a is requesting for add numbers and subtract numbers, the server should return add numbers and subtract numbers, not the divide numbers. So the RRL plays a very important role in monitoring and tracking which methods or objects each client is utilizing over the network. Any question here? If you don't want to talk, please chat so that I'm not waiting on the line for your answers.
Doctor, it says remote reference layer, right? That's the
Yeah,
one.
yeah, RRL.
References.
Yeah, RRL, yes. Okay. So, I'll proceed to the next one. Stub. So, what's the stub? So, the stub, as we mentioned earlier, it resides where? Where is it residing, the stub? Lubna, where is the stub residing? Where is this one residing? Which side? Client or the server?
Client system.
Very good. So it resides in the client. Okay, you have to remember that. So these are the sequences of events performed by the stub. Okay, first, it initiates a connection with the remote VM. You have to remember. Initiate connection to where? To the JVM. Okay, remote JVM. Containing the remote object. Okay, containing the remote object. So mostly it is the server, or it could be another client. Okay, and the next, it marshals. Okay, marshals means writes or transmits the parameters to the remote VM. So these are the steps. Marshals, okay, writes and transmits the parameters to the remote VM. What is that? If you remember earlier, in the add numbers, right, we have two parameters, correct? Do you remember it? Let me just have to go to that. It's faster. Here, right? Do you remember? In this example, we had it, right? These are the parameters, correct? Sorry. These are the parameters, int num1 and int num2, correct? So we call this the parameters here. So during marshalling, this is this one. This is the one we are putting the values for the parameters num1, which is this here. Num1 here, num1 here, num2 here, num2 here. So It is trying to write and transmit or send the parameters to the method. That is why we will be sending the value of 10 and sending the value of 20 here. Okay? So in your network, if you're going to represent it in the network, it will be like this. Okay? It will be like this. In the network, this window will be sending these parameters. num1 equals 10 and then num2 equals 20. So we are sending this value over the network. Okay, it passes over the network, this value num1 and num2. So this process, we call it marshalling. Okay, marshalling means writing and transmitting parameters. Okay, so remember that one, marshalling. Okay, like this. Okay, and then after this, the stub will wait for the result of the method invocation. Okay, method invocation. Invocation means the same as calling. Okay, when you call a method. Okay, same as the word calling. So waits for the result of the method invocation. It will be waiting. So in return, okay, in return, since in the RRL it says 192.168.x.a, which is Windows 10, is requesting to add numbers and subtract numbers, right? Agree? So what will be the response of the server? So this one, it goes down to the network. It goes down to the network. Let me just draw an arrow here so that you will see. This one goes to the network. So what will be the response of the server? Could you please tell me? Can anybody tell me what will be the response of the server? The server should respond this, right? Sum, which is equal to 30, right? Also, it will return difference equals, tell me please, -10, right? So this will be the response of the server going back to the client. Okay, so this is the direction now. Okay, like this. So this is the communication. And then after that, it will be doing unmarshalls. Okay, unmarshalls, meaning it's going to read the return value or exception return and then return the value to the caller. Okay, so what happens is, so after this, Windows 10 should be doing the unmarshalling. Where is that unmarshalling? That unmarshalling is actually this. Oh, sorry. The unmarshalling is actually this code here. This one. This. Okay. Control C. Then here, Control V. Okay. Sorry, Control V. So we'll have this. Okay, so this is unmarshalling. Okay, so this one now is the output of unmarshalling, meaning reading. Okay, unmarshalling. Okay. Okay, so this is the process. And then if it's finished, let's say for example the transaction is finished, so the stub should return the value to the caller, which is actually what? Which is the server here. So it has to tell the server that class finished, so that it will be free. Okay, and the server is ready to serve other clients requesting for different methods here. Any questions so far? Any questions so far? Please send message in the chat board if there is no question. Okay, thank you so much. Skeleton. Okay, if you will see, it's reverse, right? Have you noticed the process is reverse, right? So if you will see here in the stub, it does the marshals and then unmarshals, right? You have to remember, marshals means writes and transmit, and marshals means read. So if you will see in the process of the server, it's reverse. So the server reads the parameters sent over the network, which is num1 and num2 as an example, and then invokes the method on the actual remote object implementation, which is the add numbers or subtract numbers or multiply numbers, whatever it is. Then after this, it marshals. It returns the value and transmit it correct, returns a value or an exception. So in here, the server will write sum equals to 30, and also sum difference equals to -10, right? So this will be written by the server and transmit over the network. So expect that in your network, this data should pass, okay? And it will return the value, okay? If it is successful, meaning the code is successful, and then sum will be returned properly, or if it's an error, you remember last time, right? Exception means error. So it means that if the client made a mistake here in the code, say for example, he made a mistake on the code here, and then it should give a warning here, okay, in this portion. Clear? So if there's something wrong here, and then it should return the value in there. Okay. The RMI process is like this. Okay, so you will see this representation here. Okay, just want you to show you. So the client is invoking a method, and then it goes with the stub, and then we go the remote reference layer, and then it goes to the TCP, and then routed to the network, and then hardware interface, and then goes to your NIC, and on top. So if you will see the representation in the OSI layer is like this. So application layer is the client, maybe it's a Java code that you write, and then the presentation layer is the stub and the skeleton. The session layer will be the RRL, then the transport layer will be the TCP, the network layer will be the IP, then the data link layer will be the hardware interface, which is your NIC. So all of this will be done by the client and the server. So if you will see, all the layers of the OSI is present on this process from here to there. Okay, you know this one, right? And from here to here. So this is the process. So marshalling and marshalling, you know it, right? So the purpose of marshalling is on the transmission. Okay, marshalling will be focusing on the parameters. Okay, so parameters are either read, we read the parameters, write, and transmit, correct? So these are the process what's happening with the marshalling and unmarshalling. Marshalling means writing and transmitting. Unmarshalling means reading. So you have to remember that one, okay? So to give you an elaborate definition on that, marshalling is the process of packing, okay? We pack the parameters, okay? So this is packing. Packing means marshalling, okay? Okay, and then unpacking, or sometimes they call it bundling, packing, same thing. Unbundling or unbundling or unpacking is just same thing, okay? So they have the same meaning. If you're going to summarize it on here, let me just write it in here. Just write something. Marshalling means, can be summarized into this: writing and transmitting. Okay, so please make note of that. Also, bundling or packing, same meaning. On the side of unmarshalling, it would be what? Reading, right? Same as unbundling or unpacking. So these are the two differences to summarize everything for you. Clear? Is it clear here? Good. So the registry is the one responsible for binding and rebinding. Okay, you know this one, right? Binding and rebinding, you know this one. This is for socket programming. And then so the prerequisite for binding and unbinding, rebinding, is that client should be having a unique name. It's a prerequisite. They should have the unique name. So to invoke a remote object, the client needs a reference of that object. At that time, the client fetches the object from the registry using its bind name, so using a lookup method. So meaning in the RMI registry, there will be names of clients or whoever owning the remote object. Okay? And then in that way, we have to invoke the lookup method so that we will see the unique name or the unique name or the bind name of a specific client you wants to communicate with. So this is the RMI registry. So the RMI registry is like this. Let's look at this one. We have the client, the server, we have the RMI registry, and we have the rebind here. Invokes the method using the fetch object, both of them, marshalling and unmarshalling. And from here, fetches the object from the registry, which is lookup, and then we have the rebind. Okay, so it's not difficult to understand this discussion here. How to create a Java RMI application. So this is how you write it, and please study this one in advance because I'll give it to you as your last assignment. RMI. Okay, I might be giving this to you as your last, maybe the third assignment. Okay, please study how to create an RMI application in your Java. So these are the steps. Step 1, define the remote interface, develop the implementation class of the remote object, develop the server program, develop the client program, compile the application, and execute the application. So this is quite similar to your C# for the chat application. You'll be doing the same. So a remote interface provides a description of all the methods of a particular remote object, so the client communicates with this remote interface. Okay, so to create a remote interface, you have to write a program that will have the interface, and you have to extend it so that the remote client will be able to access that object that you will be creating, and then declare all the business methods that can be invoked by the client in this interface. So when we say business methods, this could be add numbers, subtract numbers, multiplying numbers, so on and so forth. Okay, so the remote object should have the package, so it should be the class, the classes, and everything. So basically both the remote and the client should be having JVM with them, and all the code should be written in Java. This is a prerequisite for RMI because RMI is for Java only. Okay, please remember that it's for Java only. So this is an example of your remote interface. So look at this. It says import java.rmi.remote. This is a prerequisite for running RMI. Import Java RMI remote exception. This for the error, this for enabling remote connectivity. Then you will see it writes in here public interface hello extends remote. Okay, this one. So void print message throws remote exception. This is an example, okay? So this will be a remote interface for our application. Okay, this could be running in the server side. And then you have to develop the implementation class for the remote object. So what we need to create is a code like this. Public class implementation example implements hello, then public void printing. This is an example of an RMI program. So what does it do will be simply print this. This is an example of an RMI program. So this is in the remote, okay? Very simple one. We're going to ask the server to return us. This is an example of RMI program only, this output. And then you have to develop the server program in this case. Okay, so we have to import many libraries like java.rmi server. Okay, in addition to these libraries that we imported earlier, we have to import another library for the server because we want the server to host, right, the RMI. So java.rmi server, we have to add this, and then we have to add also the Java RMI Registry. So how many libraries now we're going to add? Around 4 libraries, right? So this is your server program. Okay, so import RMI registry. So all of this you have to put in your server side, and then you will be having this object. So this is the main class for the server, and then you will have in here. Okay, just copy and paste this, it will be working. It's a very simple application. What it will do is just to say hello world. Then for the client, you'll be also adding this line, the RMI registry and the Java RMI registry. Okay, then you'll be adding this. So this on the client program. Okay, hello stub, hello registry.lookup, hello. Okay, so this is how we create a stub. Okay, and then it says hello, and we'll go with the lookup to see the hello here, and then we will expect that this one will display a hello world. So aside from the RMI, okay, we have the applet and servlet communication. This is another method implemented in Java. Okay, aside from having this this RMI, we have the applet and servlet. Okay, so this, you know what, we have plenty of Java client architecture implementation. So if you will see the first one we discussed, Java client server client architecture. The first one we discussed was RMI, right? So this remote method invocation. So we're done with this. So the other technique is what do we call servlet and applet. Okay, so this is another technique also implemented in Java. So the first one we finished earlier discussing this. So the second method is the servlet and applet. Okay, so applet servlet. Okay, so this one, the applet and servlet, is actually implemented in the web. Okay, it's in the web, so normally embedded in the HTML. You know HTML, right? You have worked with this, I think, for basic programming in the web. You will be using sort of HTML here. So we are implementing, we write the code in Java, compile it, and we're going to run it in the HTML page. So usually you will see servlet and applets embedded on web pages like this. But RMI are not embedded in the HTML pages. They are actually a standalone application. You write them, and then you compile them and deploy them in the server. You don't need HTML to run them. So the servlet and applet requires the HTTP protocol in order for them to run. So normally, same thing with the RMI. Servlet and applets use parameters, and they are being passed. But in this case, we add them at the end of the URL. We append them in the URL. So it is said that this poses security, okay, because we can't see the data on the side of the URL. That's why you will see something like, sometimes when you go from some web pages, don't you worry, you will see it when we go with the PHP programming. You'll see like this, right? Sometimes you will see like HTTP, let's say for example, let me just check one example here. This one. Have you seen this? This one here. This. Have you seen this one? That one. Okay, so this one is an example of the parameters we want to send over the applet and the servlet. So you will see it says the variable app, the value is EndNote. So we have the variable here which name is app and then EndNote. It means that I want to open an application which name is EndNote. So we're trying to pass this parameter into this URL here. So this way, since we are seeing the variable names and the value of the variables, it poses some security issues here. That's why servlets and applets, they don't earn much popularity when it comes to online transactions or online processing. But in the past, they were used to perform online transactions. But nowadays, servlet and applets are less used for the reason security is a little bit compromised. So this is an example. Maybe you have seen this in the past if you work with applets and servlets during your high school days. Maybe if you wrote programming in your high school days or even in your past semesters, then you'll be seeing something like this. So an example of an applet running on Firefox here, you will see it says this is an abstract windowing tool. AWT means abstract windowing tool. Then you have to do something like an application like this. So an applet, remember this, is a Java program that runs in the web browser. Okay, an applet can be a fully functional Java application. That's why I told you you have to write it in Java, compile it, and deploy it on a web page using HTML. Okay, so it's actually a fully functional Java application because it has all the Java APIs in it. So all the imports, all the libraries, you will import them as you write the code for this applet here. So basically, it's a fully functional Java application, but the only difference is that it runs in the web browser. So how about the servlet? So Java servlets are programs that run again on the web or sometimes on an application server, normally requiring the HTTP protocol. And the first use of servlet, as far as I remember in the past when I was still in my college days, servlets and applets were used to transact with databases to, let's say for example, connect to bank accounts, something like that. So they use them to access databases. So the servlet collects the input from the users through web page forms. So you have to create some forms and then collect them, the inputs, and then save them in the database. So it makes your database now dynamic because you can do interaction into it. So to show you the structure of the servlet architecture, it's like this. So you have the web browser, you have the HTTP protocol here, as I've told you, and then you have the HTTP servlet, and then the HTTP servlet is having programs written in it, and this should be residing on, all of these are residing on the server side. Okay, you have to remember that one. And this one is running on the client. Okay, so what happens is that you have your HTTP server, it interacts with your servlet program, and then your servlet will act in the middle and collects all the information the users placed on your form, and then save them in the database, or vice versa, read them from the database and transfer them to the client's web browser. So this is how we perceive the servlet's architecture. So nowadays we have different implementation of the servlet, the applet and servlet architecture. So we have different implementation. If you will see, we have here servlet and applet implemented in XML. Okay, and we have also servlet implemented using Oracle databases, and then we have also applet and servlet together with JSP, JSF, and EJB. So, but this time we are invoking a more secured way for the applet and servlet architecture by involving HTTPS here. So what you will see is that this is the basic structure. I want you to focus on here in the bottom. In the HTML we have the applet, then on the server we have the servlet, and then the servlet interact with the database here. Okay, so whatever you have placed on the applet, a form in the applet, will be collected by the servlet and will be passed through the database. So both of this should be residing on a server machine. So what's the task of the servlet? The servlet is simply reading data sent by the clients, normally by the browser. So this could be coming from HTML forms or also coming from your applet. Okay, if not HTML forms, it can be also coming from our applets. Okay, from here. Okay, so both servlet will be taking from HTML form, okay, or with the applet. So these are the inputs we fed to the servlet. Okay, so what happens next is it reads the HTTP request data sent by the clients. So this include cookies, media types, and compression schemes, okay, that the browser understands. So cookies will be the login details, you know this one, right? Login details, so on and so forth. Media types, if you are uploading a document like Microsoft Word and everything, if it is compressed or not. So all of this information are collected from the client before uploading it to the server. And then after this, it processes the data and generate the results. So if the data needs to be written in the database, the servlet will write it in the database. Okay, and if the process requires reading from the database, then it has to generate the results. So this way is the purpose of the servlet: read the data coming from an HTML form or the applet and generate the results based on the query. So when we talk about this, we cannot avoid but to talk about database access. Okay, but as far as the other programmers are concerned, modern programmers are concerned, they are actually suggesting RMI or Corba. Okay, RMI and Corba are a better, they are the better replacements or alternative for servlet and applets. Okay, because with this one you can get the response directly. Okay, you can get the response directly. You don't have to pass with the HTTP. So meaning server go with the transport layer directly with another client for RMI and Corba. But for servlet and applet, we need something in the middle, which is the HTTP protocol. So we need a server, an HTTP server, to stand in between the servlet and the applets there. So this would be a little bit, when it comes to performance, speed of performance, RMI and Corba will be faster than the servlet, because servlet requires a web server, while an RMI and Corba, they don't require such. So again, servlet, aside from reading, it also sends data, okay, to the clients. It sends data. Explicit data means these are documents or any output from the database that can be written, can be read by client browsers. So normally these data are represented either in HTML or XML. Basically HTML form or XML, the one you can read in the browser, okay? Or sometimes it can directly give you an image, an Excel file, or a video if you are downloading some files. Let's say for example you're trying to download the resume of your applicants in your company's website, so it can send you this data coming from your file server or your database server. And also it sends implicit response from your HTTP. Let's say for example cookies, caching parameters, so on and so forth. So these are examples of implicit. When you say implicit, these are responses that human users do not see, okay? That's why we call them implicit. This is only for machine to machine. These are machine to machine data, meaning, let's say for example the parameters, the cookies, okay, the cookies of my machine, okay, these are machine to machine. In order for the server to recognize the machine requesting for resources, and then cookies should be set. You will learn what are cookies later on, okay, when we go with the next discussion. Machine to machine. So when we say explicit data, this should be machine response of the server to humans, meaning these are the things you can read on the web page or you can download. So for you to write an application for servlet, you have to import these libraries from Java, which is javax.servlet and javax.servlet.http. But in this subject, we won't write applications for servlet, because if you'll be writing, then we won't finish the semester, because we have plenty of practicals to be conducted in the future. But for the sake of your knowledge, if you want to read this, it's good for you, okay? So servlets are initialized using init method, and then servlet calls service method to process client request, okay? So this example of bind, right? Bind, listen. So these are example of bind, listen, send, something like that. Then we have do get and do post. In the succeeding discussion, I will discuss to you what's the difference between post and what's the difference between get. Please remember this, remind me of this when we go with the next discussion. What's the difference between post and get? Okay, I'll discuss this to you soon, don't you worry. The servlet is terminated by calling destroy. So this is the example of, I think in our socket programming, is equivalent to exit, right? No, exit or close. I think close, right? In our socket programming, it's close. So they are using different method names, but same functionality. Service, this init means connect or bind, then listen, read, write. So these are on the service. So finally, the session would be garbage collected by the JVM, okay? So we have to clean the memory. So whenever we terminate a connection to the servlet, we have to clean the memory. Garbage collection means cleaning the memory, okay? You want to clean the memory. It's very important to clean the memory. So this is a sample code for the servlet. If you will see, again, this will only display hello world, okay? So client will be requesting this from the server, and then we just want to display hello world into the servlet. You see, the code is very long, but we want to display only hello world in the browser. So you will see it says the response content type should be in text or HTML, okay? And then it says in here printer writer.out response. The response here is this one, message, this is, then h1. So heading, this HTML tag, right, for heading. This is for heading. Thank you so much for joining me this afternoon. I guess we have pending discussion on Java client-server architecture. So I guess last time we were able to discuss the following. If I'm not mistaken, we were able to discuss topics on the Java client-server architecture, right? So we made a discussion on Java client server architecture. So these architectures, you have to remember, my friends, these are architecture which are implemented in Java. So please make note of that, okay? That's why we call them Java client server architectures. So I think the first one we discussed was RMI. RMI stands for Remote Method Invocation. So we're in this process, we try to access a code residing on a remote machine, and we try to access the object and the classes located on that machine. So normally RMI are applications which are requiring the JVM, right? So in order for you to run this application, you have to ensure that JVM is installed in your machines. So both machines that wish to, let me just open our past discussion so that we could go back into it. Where was that? This one. Let me just open it. So the first topic was about RMI. If you remember, in the RMI method, one source code or code is residing in the server, and we want to access it from the client machine. So if you look at it, there is this stub and skeleton. The stub is responsible for supplying all the information required to run this method, and the skeleton is accepting all these parameters being sent by a stub to the server, and these values will be passing through our network and will be processed later on by our server. And then in return, our server will return the required data after processing, and this data also passes or pass through the internet or the network. So if you will see here, the client machine here wants to add two numbers, num1 and num2, and with the value 10 and 20. So it will submit it via a stub connection to our server, to the internet, and these two values here, which is 10 and 20, will be the input for num1 here and num2, and it will be processed in the server side, which is the addition. And in return, if this is successful, sum is returned across the network. It will pass through the network again, and it will be supplied back to our clients. So in that case, the number or the sum is calculated and returned back to the client. So this is a basic illustration on how this happens in the RMI environment. So this is the example, and if you remember last time, whatever operating system, we require that all of these machines should have the Java virtual machine installed. All of them should have JVM installed, because you have to remember, communication between the stub and the skeleton is being done inside the JVM. So you have to remember that processing of the RMI is being conducted or being done within the Java virtual machine. So this happens within the JVM itself. So all machines, whether it is Windows, it is Linux or Macintosh, they should have JVM installed, and also they should have JDK installed in each operating system in order for them to communicate over the network. So RMI stands for Remote Method Invocation. And as far as I remember, last time we also discussed about applet and servlet. So applet and servlet is another Java implementation, okay, of client and server architecture. So we have the applet and servlet. So if you remember last time, we discussed that applet and servlet specifically were designed to run in web browser. So they are required to run over the web browser, if you remember it, right? So they require a protocol which is HTTP or HTTPS to run this application. So you will see now the difference between the two. So basically, applet and servlet, they run over the web browser, and while Java client are running on the JVM. Okay, so meaning they are a full standalone Java application. So just to note it, they are full standalone Java application. Okay, for the RMI. So they require this JVM to be installed in order to execute them in the RMI mode. But for the applet and servlet, we only require the web browser and the HTTP protocol to run this. So it runs over the web. So I've discussed to you, I think I stopped here last time, and I represented to you how applet and servlet are being used nowadays. So as I told you earlier, we embed our applet in the HTML, okay, in a web page. That's why it requires a web browser and the HTTP protocol to run, because we embed it. The applet is embedded in an HTML code, and from there we run it, and then this applet communicates with the servlet. Okay, it communicates with the servlet here, wherein this servlet is actually stored on an application server. And the servlet now represents, or it's an intermediary between your applet and your database. So it means all the processing are being done on the servlet, and the collection of data is being done on the applet. Okay, so users themselves, they input the data in the applet. So we use it. The applet is now is used to collect the data, and then we supply it to the servlet. The servlet will do the processing, like calculation or inserting it to the database, so on and so forth. So all the processing are being done here, and this one we do the collection. We only receive or send data to our servlet, and the servlet will store it or transact into our database. So also we have plenty of sample illustrations on how applet and servlet are being implemented in real life. So, but if you will see, most of them are requiring what? HTTP, right? So it requires a web browser in order to run this applet and to communicate with the servlet here. I guess I've asked you a question last time and we're done with it. So I also discussed to you the job of the servlet as far as I remember. I discussed to you what's the purpose of the servlet and also the purpose and the task on how servlet accept inputs from our users. Okay, so basically a servlet collects all the information from our HTTP clients, and if you write a code for the servlet, you have to import this in your Java code. So if you remember your C sharp, right? In our C sharp, whenever we write a code, we have to do the using, right? On the top of the code, we are importing some libraries. So likewise, when you write application in Java, you're also required to have a reference with the libraries, so that you'll be able to access the functionality of servlet, and also for you to able to access the functionality of HTTP. As I've always mentioning since earlier, servlet and applet, they operate over the HTTP protocol, so you have to make note of that. So let me just go back with this. If you remember last time, so servlets have life cycle. So the servlet is initialized, okay, by calling the function init, and then the servlet calls service method to process a client request. So whenever this method is invoked, and then the servlet or the server is capable now on accepting process requests. So this request can be done with do get and do post. I think I discussed to you this one, right? These two, I discussed them to you last meeting. Do get means when we write the URL on the top of the web browser, we see the variables displayed, correct? If you remember last time, I showed you an example. When we go with the do get, the variables are stored on the URL, and when we go with the do post, your data on the top of the URL are encrypted. If you noticed last time. So if I open one, let's say for example, let me just open one example here. This one. So if you will see, it says on the top m equals to 1, right? So this is the effect of the do get. Later on you will see this when you go with HTTP discussion next meeting. So this is the effect of the do get. In the do get, you will see variables listed on the top of the URL, m equals to 1. But in the do post, you won't see any variable being passed here. Let's say if I go with the Moodle, let me just try if the Moodle is safe. So if I log into the Moodle, have you noticed that one? When I press the button login, nothing was displayed here about the variables. My username and password were not listed here on the top of the screen. Later on you will see it when you go with the discussion, when you go with the HTTP and PHP programming. When I click visual effects and 3D animation, let's see what happens. What have you noticed here? A variable was shown, right? Have you noticed it says Muscat College at edu.om Moodle course view PHP ID 9P. Okay, it means that in the database of Muscat College, the Moodle database, visual effects and 3D animation has an ID of 90, meaning it is the 90th course stored on the database of Muscat College. That's why it is ID 90. So this one is using the get. Okay, the get method. So the get method displays everything, the variables here. So it means I want to view the subject with a variable name of 90. So in this way, the value of the ID of this course is displayed in the URL. Soon, when you go with the discussion, you will know what's the purpose of having this. Next, if the servlet service is finished, then we have to terminate it by calling the destroy method. So the destroy method is equivalent to the word close, right? And finally, servlet is doing the garbage collection. Garbage collection is a concept in Java, especially in the JVM, to clean the memory, to free up the memory space so that other client may do the requests later. Okay, so it is a good practice that whenever you terminate an application, you have to do the garbage collection, meaning you have to free up the memory space and disk space if necessary, so that the resources will be assigned to a new request, to a new client. So I guess this is an example of the coding for the applet and servlet, the one I discussed to you last meeting. So if you will see it in here, we want to display the hello world. Okay, in the side of the servlet, we have the hello world here. So basically, what this will do is to display hello world. So it uses the function doGet to return the value, which is in form of HTML or texts, and then it will display it in a form of message box which says hello world. And then after this, public void destroy, it won't do nothing because it's only a method built into the library of the servlet here, the library servlet here. The purpose is just to destroy or close the connection or the transaction. And also, let me just go with it. So just to illustrate to you in the diagram how it's being handled, again, you have to remember whenever we perform client-server programming in Java, Java virtual machine is always required. So please make note of that. Okay, whether it's running on the browser or not, you have to remember that the Java virtual machine or JVM is required. Okay, whenever you create this, what do we call Java based client and server applications. So again, if you will see multiple threads, okay, multiple threads, or meaning when you say multiple threads, you know this one, right? In systems programming, when we say multiple threads, we're referring to multiple process running in the machine, and this process has multiple sub processes which we call threads. So basically, this concept of multi-threads are being handled by the Java virtual machine here, and then being passed through the web server or our servlet server here. So basically, as I've told you earlier, all processing is being done in the Java virtual machine. Okay, so let's try to differentiate or compare the two. I think I discussed this to you last time. Okay, I discussed this to you last time if you remember. So applets and Java application are somewhat the same. Okay, the only difference is that an applet runs in a web browser. Okay, so they are embedded in the HTML page. So meaning an applet is required, a web browser is required for an applet to run. Unlike in the Java application, it's a full standalone application that doesn't require embedding in the HTML or doesn't require a web browser to run. So you have to look at this. So whenever a user views an HTML page that contains an applet, the code of the applet is downloaded to the user machine. So this is a client-side based scripting, meaning this code, the applet code, is downloaded on the user machine. Okay, so it runs in the HTML page. It requires a browser to run it. So both of them they are requiring the JVM. Okay? And the other difference is that a Java application has a main method. Okay? It's having the main. You know this one, right? Whenever we write the code in C#, in C, or in Java, we have the main method like this. So this main method is not present in an applet. Okay? They don't have main. So applet doesn't have main. Okay? Where on the other side, a full Java application is having a main. So it requires a main function to run. So from the main function, it could jump to any part of the code. So unlike in an applet, the main method is not present. Next, we have sandbox, right? Do you know sandbox? Do you have any idea what's a sandbox? So a sandbox is like this. If you see these two children, right? So these two children, we call this environment a sandbox, correct? So if you will see, you don't have to bring these two children to the sea or to the beach for them to play in the sand, right? Or you don't have to bring them outside your house to play in the sun. So what you have to do is you have to create a sandbox inside your house, maybe, or in your residence, and put some sands here. So the idea here is whatever things or whatever game the children plays on the beach can actually be done inside a sandbox, because a sandbox try to copy or try to simulate how a real beach or sea works. After all, the concern of the children only is to play on the sand, right? So we don't have to bring the entire beach to the house so that children can play in the sand. But instead, we just have to get some sand in it and put it in the sandbox and let children play. Likewise, the principles of JVM is like a sandbox. Okay, it's like a sandbox. So we try to run the application within the context of the JVM or the virtual Java machine, and each instance of the applet can invoke various methods during the applet's lifetime, again inside the Java virtual machine. So in this case, you can actually secure your codes in Java because it runs in the JVM, meaning the real operating system won't be able to gain access with the source code of the applet, because the source code is running within the JVM as a separate entity, like a sandbox here. Correct? So the real operating system will not be able to gain access with the source code stored on the JVM. So in this case, security is enforced. Okay? So security is enforced because it requires the code to run only on the JVM, and JVM of course is a special area, and of course the developer of Java made it sure that whatever source code running on the JVM is not exposed on the real operating system. Therefore, compromise in the security is lesser than running the code on the operating system itself, because we know for a fact whatever running on the OS is free for access for external people, right? Like the hackers. So the hackers can gain access with what is inside your OS. So it means that in order for the hacker to gain access with the source code in the JVM, it has to pass through first the OS. So if the OS has a very nice security system, and then it is difficult for the hacker to penetrate on the JVM. And again, JVM itself has a built-in security mechanism in it. So even though the hacker is able to access the OS, it won't be able to access the JVM because security is reinforced in JVM, like a sandbox here. So for you to be able to incorporate some other applications or some libraries in your applet, you have to download extra Java, what do you call this one, extra Java programs or libraries in a form of jar. Okay, so by the way, jars are the packaging file for Java applications. So normally classes are compiled into jar files, okay, and jar files later on are being imported on your application in order for you to, let's say for example, if you're writing code, some of the libraries you need are not supported or not present in your Java application, your compiler, so you could use third party. Okay, third party, when I say third party, these are classes made by other people. Normally you could see them in GitHub. GitHub is a very good website that provides you all third-party software. Let's say for example here we have Dragon. Okay, so this is for C# implementation of naive Bayes for artificial intelligence. So if you want Java, you can specifically write Java here, and then they will give you Java classes. So meaning these are third-party classes that written by other people and which are not present currently in your programming language, or I mean your compiler. Let's say for example in Visual Studio, if I want to write a code for this function for naive Bayes, I cannot see this library. Actually, this is not available in C#. So for me to get it, I have to download these classes here and then import it in my project. I have to import them in my project in C#. Likewise in Java, if you want to access functionalities from other classes, you have to download a Java file and a jar, okay, extract it, or if not necessarily, you just have to reference it in your Java environment, development environment, like this Eclipse or like NetBeans. Import them and then access the other libraries. So how about the life cycle of the applet? So the life cycle of the applet is represented in this figure here. So an applet is initialized. Okay, it is initialized. Then after it is initialized, it starts, and then the applet starts running, or an applet could be stopped for the meantime and started again, and then go with the cycle. Okay, so when a web browser is closed, let's say for example you close the web browser, or the web browser is redirecting to another web browser, so your applet is being destroyed. Okay, so when it's destroyed, meaning it is being removed from the memory of your computer, and your computer is doing the garbage collection, and the memory is free up. So this is the cycle from init to start and then to stop. So this is basically the process your applet is undergoing: init, start, stop, start again, go with the cycle, then when you are done, then you destroy it. Basically when you close the web browser, you destroy the applet. When you open the web browser or a web page having an applet, then you initialize an applet. So when you write data in a text box or in an HTML form, and then an applet starts running. So during running time, an applet could send data to the servlet, and the servlet process it and send it to the database or a file server, depending on what setup you are having in your company. So when the processing is finished, we stop the applet, or even we destroy the applet. So you have to remember, you cannot destroy an applet unless and otherwise it is stopped. So you have to stop it first before you can destroy it. In the destroy cycle, the method, or as I've told you earlier, destroy is being called when the browser is closed, or the browser is shut down, or a page is closed. Okay, you have to remember, applets are meant to live on HTML page. So if you close that HTML page, then your applet is destroyed. So paint is a method that is invoked after the start. So actually paint means is synonymous to when you run your Java applet, paint comes into the scenario. Paint means if you have GUI, if you have, let's say for example, if you have what do you call this one, if you have forms like this, login, text box here and text box here, and then there's a button, it says login. Okay, so during the init phase, GUIs are being shown on the screen as part of the web browser. That's the effect of the paint. And paint is actually on Java AWT. Okay, Java Abstract Windowing Tool. Java Abstract Windowing Tool. So Java Abstract Windowing Tool provides you a window. It's like a form, the one you are designing in Visual Studio. Do you remember in your C#? You are designing text boxes, buttons, and like this. So that one is being provided by the library java.awt, or Abstract Windowing Tool. So during the start method, paint is invoked, and during paint, the GUI is being displayed little by little to in your web browser. You won't notice the paint method because nowadays we have very fast computer systems, right? So the painting or the showing of the forms and the controls and the buttons, the text boxes, and whatever it is in the web browser is very fast. So this is an example of the Hello World applet. So you will see it says import Java applet, and then we have AWT. AWT, if you remember last time, this is about Abstract Windowing Tool. So we want to create a GUI. So basically this class here will just create, we'll draw this string hello world in X and Y position. Okay, so it will be showing a square like this on the screen. Okay, and hello world is positioned on 25 and 50, so maybe it's somewhere here, hello world. So when it runs in the web browser, it will be like this, hello world. So the applet class provides you all of the following. Okay, the applet class, the one I showed to you earlier, this one, it could provide you all these functionalities. If you want to go with parameters, parameter is only synonymous with the word variables. Okay, the one you want to pass, these are the data you want to pass to your servlet. And also if you want to get the network location of the HTML file, also you want to get the network location of the applet class. And then if you want to print the status message in the browser, like a dialog box like this, are you sure you want to exit? Then you can have in here yes, then you can have in here no. So these are part message boxes. Okay, so message boxes are being shown. And if you want to display an image, or if you want to play an audio clip, you want to fetch, you want to download image from your servlet, you can do so with the applet class. You can also play audio clip, and you could also resize the applet. Okay, if you want to drag it and resize, so normally you can do it in the applet class. So when you invoke the applet, look at this. You have your ordinary HTML code here, HTML, close HTML. For those who have programmed HTML, you know what I mean. But for those who haven't programmed HTML, you will learn it more when we go with the next topic, with the client side and server side scripting language. You will learn how to write codes in HTML and PHP. You will learn it soon. Don't you worry. Just relax for now. But for those who took it in their UMP courses, maybe in the web scripting and web application development, this is not challenging for you. It's not difficult for you because you took it with Miss Akila, I think, and Miss Smita. So it's not difficult for you to get what I mean here. But for the SQL people, for I think Ali, Zainab, Hani, Azam, I think you did not program, right? You did not do programming like this in SQA, right?
No, Doctor.
Yeah, so we have to discuss a little bit longer on this so that the 5 of you would be able to grasp what we're talking about in here. Because your project actually requires you to write code in HTML, PHP, Java, and C#. So all of it you are required to do. Okay? So
Yes,
if you want to invoke this applet, you have to embed it using the applet tag. Okay? The applet tag here, you have to embed it. So you have applet. Okay? And then you have another tag here which is close applet. So within the applet tag here, you have to embed. So in this class, it says applet code hello world applet class, which was this, the one you have written earlier. This one is the applet class. So you have to write this separately on another file, and then later on we will call it in the applet code here. Okay, we will call it later. Then you want to display it with a width of 320 and 120. So it will, if your web browser is like this, then you could show what's the size of that applet. So maybe your applet will take a space in your web browser. Then the rest, it will be doing something like this. So the output of that will be something like this. Okay, it says hello world. So this is how you will do it with your applet and servlet. So I think I am done with this first part for the Java-based client and server architecture.